All right, let's go ahead and discuss Lesson 8.2, Pythagorean Theorem in its converse. Recall that the Pythagorean Theorem states that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Now remember, the hypotenuse is essentially across from the 90-degree angle. It's the longest side of a right triangle. So here, this is my hypotenuse. Because one, it's the longest side. Two, it's across from the 90-degree angle. So if triangle ABC is a right triangle with right angle C, then we can say that a squared plus b squared is equal to c squared. So let's go ahead and figure out what example 1 is. Find the value of x, if possible, leave your answer in simplified radical form. So using my formula, a squared plus b squared equals c squared, where x is c because it's across from the 90-degree angle, I can go ahead and plug that in. So I have x squared. And a and b, it doesn't matter which one's which, but we know that these two are not the hypotenuse whatsoever. So going to plug those things in, I got 6 squared plus 15 squared. 6 squared is 36, and 15 squared is 225, which is equal to x squared. Now 36 plus 225 is 261. I equal that at x squared still, but now I'm solving for x, so I'm going to take the square root on both sides. So I get, well, the square root of x squared is just x. And then the square root of 261, I need to make sure I'm leaving my answer in simplified radical form because that's what the instructions told me what to do. So the square root of 261, I can break that up. I'm thinking the square root of 9 times 29, because 9 times 29 is 261. The square root of 9 is 3, so 3 is going to go on the outside, and 29 is going to remain in the inside. So I have 3 root 29, and that is my answer for x. So b, okay, I have a right triangle. I'm going to use a squared plus b squared equals c squared. Figure out what c is. It's across from the 90-degree angle. That's 11, so I can go ahead and plug in my c. That's 11 squared, and everything else, it doesn't matter. So it's x and 9. So x squared plus 9 squared, x squared plus 81 equals 121. I'm going to get x squared by itself. So if I subtract both sides by 81, I'm going to get x squared equals 40. Now, if I take the square root on both sides, well, I'm left with x on the left-hand side, and I have square root of 40. Again, I need to leave my answers in simplified radical form. So I'm going to break down 40. I'm thinking 4 times 10, because 4 times 10 is 40, and I want to have one of the numbers be a perfect square. So I have the square root of 4 times the square root of 10. The square root of 4 is 2. And then the square root of 10 is just going to be the square root of 10 because I can't break that down even with, 5 and 2. So x is equal to 2 root 10, and that is my answer. All right, for c, again, we have a right triangle. I'm going to use my formula, my Pythagorean theorem, a squared plus b squared equals c squared. C will always be across from the 90-degree angle, and we can call this a and we can call this b. So I have x squared plus 4 root 3, the quantity squared, equals 8 root 3, the quantity squared. So that's x squared, and then 4 root 3 quantity squared is basically 4 root 3 times 4 root 3. So I can do 4 squared, so plus 4 squared, which is 16, and then root 3 squared, that's 3. So 16 times 3. Because if I'm doing 4 root 3, the quantity squared, and everything is multiplication here, it's safe to multiply these two things after you figure out, what 4 squared and root 3 squared is. Okay, so I'm going to set that equal to, I have 8 squared, that's 64, and I have root 3 squared, that's times 3. So let me go ahead and simplify this. I have x squared plus 48 equals 64 times 3 is 192. You're solving for x squared, so you're going to subtract both sides by 48. So x squared is equal to 144. Okay, so now I need to take the square root on both sides, and I know that 144 is a perfect square, so x is 12. X is equal to 12. All right, let's look at D. We have a right triangle once again, and this is my hypotenuse. So x is C, and this is A, and this is B. So a squared plus b squared equals c squared. All right, we'll call this a because I can't remember which one's which. So this is a. So 3 squared plus x minus 2, the quantity squared. So make sure you put the parentheses when you have an expression just like this, is equal to x squared. So 3 squared is 9, and then this x minus 2 quantity squared is essentially x minus 2 times x minus 2. And if I FOIL, I get x squared minus 2x plus 4, which is x squared minus 4x plus 4. So I can rewrite that as 9 plus x squared minus 4x plus 4 equals x squared. Notice that I can combine these two terms here. So I have x squared minus 4x, and I got 9 plus 4, which is positive 13, which is equal to x squared. Subtract both sides by x squared, because you can see that the left-hand side of the equation has an x squared and the right-hand side of the equation has an x squared as well. So you can subtract both sides by x squared. Okay, so I'm left with negative 4x plus 13 equals, well, what's x squared minus x squared? That's 0. So I'm solving for this pesky x right there, so minus the 13 on both sides, so negative 4x is equal to negative 13. So x is equal to 13 over 4, and that is your answer. X is equal to 13 over 4. Okay? So that is D. Let's take a look at E. It says the sides of a triangle have lengths x, x plus 7, and 13. If the length of the longest side is 13, what value of x makes the triangle a right triangle? So 13 is the longest side of that right triangle, so we can call that C. Using my formula, a squared plus b squared equals c squared, I can go ahead and plug C with 13, so 13 squared there. Here's A and here is B, so it's x squared plus x plus 7, the quantity squared, is equal to 13 squared. So this becomes x squared plus 14x plus 49 equals 13 squared. And by the way, x plus 7 quantity squared is equal to x plus 7 times x plus 7. And once you FOIL that, you should get this. Okay, so this 13 squared is actually 169. Notice that I can combine two of these x squares. So x squared plus x squared is not x to the 4th power. It's actually 2x squared plus 14x plus 49 equals 169. And look at that. This looks like where I need to use the x method. So I'm going to subtract both sides by 169. So I have 2x squared plus 14x, and then plus 49 minus 169, that's minus 120, equals 0. Okay? So you have this. You can factor a GCF out of this expression, this trinomial here. So I'm going to go ahead and do that right now. What number goes into 2, 14, and negative 120 at the same time? 2. So if I factor that 2 out, you're going to get x squared plus 7x minus 60. And what does that equal to? It's going to equal that 0 here. So then if I pay attention to this trinomial, I can use the x method for that. So I'm going to draw my x. Negative 60 goes up top. 7 goes in the bottom. What two numbers multiply together that will give me negative 60 but add to 7? Well, that's going to give me, or I'm thinking 12 and negative 5, because if I do 12 times negative 5, that's negative 60, and I do 12 plus negative 5, that's just 7. So these two factors do work. So I write 2 times x plus 12 times x minus 5 equal that to 0. And then, okay, what are the x values? So if I do, okay, I'm going to put x here, x equals. So take this factor, set that equal to 0. So x plus 12 is equal to 0. If I subtract both sides by 12, I get x equals negative 12. So negative 12 is one of my answers. And you have this other factor. I have x minus 5 equals 0, so x is equal to 5. So x is equal to 5, okay? So my two answers are x equals negative 12 and x equals 5. But what is the best answer that will satisfy the context of this question? Because we are dealing with lengths, right? We're dealing with a right triangle which has lengths, you know, x plus 7 and 13. So if I plug in 5, okay, one of the sides of this right triangle is 5 units long, and if I plug in this 5 to this expression, that's going to give me 12. So the side lengths of this triangle is 5, 12, 13. Okay? So the best answer would be x equals 5 because we're dealing with lengths. We're dealing with a right triangle. Lengths are always positive. There's no such thing as a negative length, because if I plug negative 12 in, well, this is negative 12. We don't want that because that right triangle would have a negative length, which doesn't exist. And then negative 12 to this expression, negative 12 plus 7, whatever that is, you're going to get a negative still. You still don't want that. So your best answer, the best answer to box in would be x equals 5 because it will satisfy the context of that question. Okay? So please make sure that you are reading the question properly and then figuring out which is the best, or what is the best answer. Now, let's take a look at F. The sides of a triangle have lengths 3, root 27, and 5x. If the length of the longest side is 5x, what value of x makes the triangle a right triangle? We're dealing with the right triangle. We know that the length of the longest side is 5x, so I will do a squared plus b squared equals c squared. A squared plus b squared equals c squared. C is going to be 5x. So I can go ahead and plug that in, and then this will be a and this will be b. So I have 3 squared plus root 27 quantity squared equals 5x quantity squared. 3 squared is 9 plus root 27 quantity squared. Well, that's root 27 times root 27, which is simply just 27. And I equal that to this 2 gets distributed to the 5, and this 2, the same 2, gets distributed to the x. So it's 5 squared times x squared, which is just 25x squared. So 25x squared for that one. 9 plus 27 is 36, and I equal that to the same old 25x squared, which I found out 2 seconds ago. Okay, I'm solving for x. There are 2 ways to do it, but we taught you to move, one side to the other and have that, other side be 0. So I'm going to subtract both sides by 36. So the left-hand side of this equation is 0, and I equal that to 25x squared minus 36. This right here is an example of difference of 2 squares, because 25 is a perfect square, 36 is a perfect square, and we can't forget that little x squared there. That is also a perfect square. And all of these terms, these perfect squares, they're separated by this minus sign here. So 0 is equal to 5x plus 6 times 5x minus 6. So then I'm not done because I need to solve for the indicated variable. I'm solving for x. So take this factor and set it equal to 0. So you get 5x plus 6 equal to 0. If you subtract the sixes, if you subtract 6 on both sides, you get 5 equals -6, so x is equal to -6 over 5, okay? That's one of your answers. Let's do the other factor. Set that equal to 0, so 5x minus 6 equal to 0. 5x equals 6, so x equals 6 over 5. And look at that. Both of my answers here are 6 over 5, where one of them is positive and one of them is negative. What is the best answer to the context of the question? The answer is 6 over 5. We want the positive x value, and we don't need this negative whatsoever. Okay, so that's F. All right, I'm gonna go ahead and clear this out. So Malik goes hiking around a lake. He wants to walk to the other side. To get from point A to point B, Malik has to walk 6 miles directly south. So here's point A, and he's going to go 6 miles directly south. So we're going to call this 6. And then he's going to walk 8 miles directly east. And that's how he gets to point A. Or sorry, not point A, point B. So he goes down, that's 6, and he goes east, that's 8. The question is, if Malik could go directly across the lake from point A to point B, how many miles shorter would the distance be? So if he's going to, walk on water or, use a boat to get from point A to point B like that, well, we don't even know how long that would be. So we're going to call that X. And this is a right triangle because it's perpendicular. He's going from south to east. That creates that right angle there. So this is a right triangle. We're dealing with Pythagorean theorem. And we know that X is the hypotenuse. So using a squared plus b squared equals c squared, I can plug everything in. So I have 6 squared plus 8 squared equals x squared. So 6 squared is 36 and x squared is 64. I equal that at x squared. 36 plus 64 is 100. Again, equal that to x squared. Take the square root on both sides. So you get 10 equals x. So from point A to point B, if he's walking diagonally just like so, that would be 10 miles long. X is equal to 10. But that's not what it's asking. Or the question's asking if Malik could go directly across the lake from point A to point B, how many miles shorter would the distance be? So originally, if he goes from point A to point B just like this, well, that's going to take him 14 miles in total. So originally, that would be 14 miles. But if he were to walk if he went from point A to point B diagonally, if he can walk across the lake for some reason or go across the lake, well, that would take him 10 miles. So that would take him 10 miles across the lake. So how many miles shorter would the distance be? Well, it's just going to be 14 minus 10, which is just 4 miles shorter. This is your answer. Now, 6, 8, 10 is an example of a common Pythagorean triple. Now, a Pythagorean triple is a set of 3 non-zero whole numbers a, b, and c such that a squared plus b squared equals c squared. Common Pythagorean triples 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now, 3, 4, 5 works because if I do a squared plus b squared equals c squared and plug them in, you know that 5 from this set of triples, the longest side is 5, so that should be my c. So I have 3 squared plus 4 squared equals 5 squared. 3 squared is 9, and 4 squared is 16. And 5 squared is just 25. 9 plus 16, 25. Yes, that's going to be 25 for the left-hand side. And then on the right-hand side, That's 25. The question I'm going to ask you, is the left-hand side equal to the right-hand side? Yes, so that's why that 3 squared plus 4 squared is equal to 5 squared, because the left-hand side agrees with the right-hand side, okay? And that also works for 5, 12, 13, 8, 15, 17, and 7, 24, 25. You can go ahead and plug those into the Pythagorean theorem to see if the left-hand side agrees with the right-hand side. Okay, so if I have 3, 4, 5, and I double that, that's going to be 6, 8, and 10. This is a triple, and it works. If I take my original triple, 3, 4, 5, and I triple that, I get 9, 12, 15, and I use this, the left-hand side should equal to the right-hand side. So the rule here is I do 3 times whatever x, or 4 times whatever x, and then 5 times whatever x. You're going to get the result of, where the left-hand side is equal to the right-hand side. And that should apply to these examples over here.
Teachers and students, at this time, if you have not already done so, please work with your teacher on your course planning form for course advices for your lessons for next year. Thank you.
Okay, so we're going to go ahead and use this idea to figure out these examples. So I have a right triangle. One's 48, one's 20. Let's figure out the greatest common factor between 48 and 20. What number goes into, what is the highest number that goes into 48 and 20 at the same time? I'm thinking 4. 4 goes into 48 12 times. So I'm going to write 12 times 4, just like so. Right? I'm gonna put parentheses around my GCF, because 12 times 4 is 48. And then what number times 4? What number times 4 is going to give me 20? That's 5 times 4. That's 20. So notice that I have a 5 here, 12 here. Can we figure out what the pattern is? How do I figure out what x is? So it's 5, 12, 13. So I'm going to have 13 times 4, and that is 52. So x is 52. That's how long the hypotenuse of that right triangle is. And then here's B. Okay, so let's figure out the GCF. What number, or what's the highest number that goes into 14 and 50 at the same time? I'm thinking 2. So 25 times 2 is 50, and 7 times 2 is 14. So if I have 7, 25, let's look up. Look at that. We have 7. We have 7 here. Here's 25. So this must be 24. So 24 times the GCF, that is 48. So x is equal to 48. The triangle inequality theorem. This is the step 1 to show what type of triangle this is. First of all, the purpose of this is to show you with 3 points, can we form a triangle? Now, the triangle inequality theorem states that the sum of any 2 sides of a triangle must be greater than the length of the third side. So if I were to look at this example here using 8, 5, and 10 as my measures, these numbers allow me to create a triangle. And again, remember, with the triangle inequality theorem, it states that the sum of any 2 sides of a triangle must be greater than the third side. So suppose that 10 is my third side. Here's 10. What are the 2 numbers that I did not pick? Well, it'll be 8 and 5. So 8 plus 5, you want to compare that to that third side here. 8 plus 5, is that greater than 10? If this is greater than 10, then you're going to put a check mark, because you showed one combination, but you have to show the rest. So we already picked 10 as our little main character here. Let's take a look at this 5. That's our next main character, 5. What are the 2 numbers, not 5? Well, that's 8, and that's 10. Now I look at 8 and 10. I'm going to add those 2. That's 8 plus 10. 8 plus 10 is 18. Is 18 greater than 5? Yes. Put a check mark there. Let's do one more. Our main character is 8 now. That's the last number I haven't chosen yet, but now I will. So here's 8. What are the 2 numbers? 5 and 10. Are 5 and 10, if I add those 2 numbers, greater than 8? So that's 15, greater than 8. Yes, You will check that, and you're going to say, okay, I've tried out all the combinations. They do work, so it is indeed a triangle. For an example that, isn't a triangle, suppose you have 2 feet, 5 feet, and 10 feet. So if I pick 10 as my main character, and here's 2 and 5, those are not my main characters at all. If I add those two numbers, is that greater than 10? Well, 2 plus 5 is 7, and I compare that to 10. Is 7 greater than 10? No, it's actually less than 10. So with those measures, you cannot form a triangle with those measures whatsoever. Okay? So you stop there. Let's take a look at this example. Determine whether the following measures form a triangle. Okay, so it's basically what we did over here. I'm going to pick 25, that's my main character, and then 7, 21 are the numbers that I did not pick originally. So I put 7 plus 21, compare that to 25. Is it less than or greater than? Well, 7 plus 21 is 26, so 26 is indeed greater than 25, so I can go ahead and check that. The next thing I'm going to do is I'm going to pick 21. The numbers that I have not chosen were 7 and 25. 7 plus 25. If I do 7 plus 25, is that greater than 21? Yes, I don't necessarily need to add those two numbers because I know for sure that 25 is, greater than 21. So I don't really need to, add those two because it's already a given. So 7 plus 25 is indeed greater than 21. And then we're going to do 7 here. 21 plus 25, yes, obviously greater than 7. So I tried out all the possible combinations. Yes, it forms a triangle. So I'm going to write triangle. Okay, let's take a look at B. So 12, I'm going to compare that to 5 plus 7. 5 plus 7 is actually 12. So the left-hand side, compare that to the right-hand side, it's actually equal. Since 12 is not greater than 12, 12 is equal to 12, we cannot form a triangle at all. Okay, let's take a look at the last page together. So in the previous page, you have learned how to prove whether a figure is a triangle given 3 measures. Step 1. In this page, you will classify what type of triangle using the 3 measures. So you have the converse of the Pythagorean theorem. It states that if the sum of the squares of the lengths of the shortest sides of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle. So in summary, if I'm going to say c squared is equal to a squared plus b squared, then you have a right triangle. Okay? And when we've shown that the measures form a triangle and we're trying to classify whether or not, what type of triangle that is, what I want you to do is I want you to write c squared first on the left-hand side of the equation, and then everything else on the right side of the equation. And I will demonstrate why when we get to some examples here, okay? So, if the left-hand side is equal to the right-hand side, then you have a right triangle. Here's some more. If the sum of the squares of the lengths of the shortest sides of a triangle is greater than the square of the length of the longest side, then the triangle is acute. So in summary, if, again, I like to have my c squared on the left-hand side, if c squared is less than a squared plus b squared, then you have an acute triangle. Now, if the sum of the squares of the lengths of the shortest sides of a triangle is less than the square of the length of the longest side, and then the triangle is obtuse. So that means if c squared is greater than a squared plus b squared, then you have an obtuse triangle. So let's look at some examples here. Determine whether each set of numbers can be the measures of the sides of a triangle. So this is step one. Step one. Now, if step one is successful, then you get into step two. So let's do step one for A. So we gotta figure out whether or not these measures form a triangle. I have 9, 12, 15. So I'm gonna write 15, 12, and 9. So since 15 is my main character, the numbers that I did not choose were 9 and 12. So 9 plus 12, is that greater than 15? Yes. Here's 12. I'm going to say 9 plus 15, is that greater than 12? Yes. And then look at 9, 12 plus 15. If I add those two numbers, whatever the result is, that greater than 9? Yes. So with this forms a triangle because all the combinations do work. All right, let's take a look at B. Oh, sorry, we're not done because we gotta classify whether the triangle is acute, right, or obtuse. So since step one does work, I can move on to step two. If step one does not work, you should not move on. So step one succeeds. Let's go ahead and figure out whether or not the figure is acute, right, or obtuse. So I like to write c squared here on the left-hand side, just like I mentioned before. And then on the right-hand side, you should have a squared plus b squared. So what is c from this set here? Well, it should be 15 because that's the longest side. So c should be your 15. Or 15 should be your c. So I have 15 squared, and then we got 9 squared here plus 12 squared there. 15 squared is 225, 9 squared is 81, plus 144. 81 plus 144 is 225. So compare the left-hand side to the right-hand side. Compare c squared to a squared plus b squared. Well, is the left-hand side equal, greater, or less than the right-hand side? Well, it's going to be equal to, so if it's equal to, then we have a right triangle. Okay, so that was step two of this process. Let's take a look at B. I'm going to do 9, 7, 5. 5 plus 7 is greater than 9. And then let's see. 5 plus 9 is greater than 7 because obviously 9 is greater than 7. And then here's 5. 7 plus 9, is that greater than 5? Yes, because 7 is greater than 5 and 9 is greater than 5. Or 16 is greater than 5. So with this set here, it forms a triangle. Now, what type of triangle is that? Well, again, I'm going to do c squared and then a squared plus b squared on the right-hand side. Now, c squared, well, what is c? C is the longest side, so that should be 9. So 9 squared compared to 5 squared plus 7 squared. That's 81 on the left-hand side, and then 5 squared plus 7 squared. If I put that in the calculator, that should give me 74. Now compare 81 to 74. Is that less than, greater than, or equal to? Well, 81 is greater than 74, so we have an obtuse triangle. Because if we look, if c squared is greater than, or if c squared is greater than a squared plus b squared, then it is an obtuse triangle. And then here's c. We're going to do 20, 13.8, 6.2. 20 is my main character, so 6.2 plus 13.8. Okay, if I were to add these two, that's 20, and it equals to the right-hand side. So I can stop here and say, not a triangle. Not a triangle. All right, let's look at D. Okay, so here's 12. Here's 11, here's 10. 10 plus 11, that's greater than 12, check. Here's 11. Here's 10 plus 12, that's greater than 11, check. Here's 10, so 11 plus 12 compared to 10. 11 plus 12 is obviously greater, so check. This forms a triangle. You finish step 1, you want to move on to step 2. So write c squared on the left-hand side, and then on the right-hand side, you write a squared plus b squared. So c should be 12 because that's the longest side, and then your a and your b are the ones that are not 12. So we got 10 squared plus 11 squared. 12 squared is 144, and then 10 squared is 100 plus 11 squared, that's 121. So 100 plus 121 is 221. So compare c squared to 221. Is c squared less than, greater than, or equal to? It should be less than. So what type of figure is this? It's an acute triangle.